Hello everyone. Welcome to the Tim Booker channel. Wishing you a pleasant listening experience. Today, the book I'll be interpreting for you is The Diet Myth. In today's information explosion, we are constantly bombarded with various messages about healthy eating. Is a low-fat diet really right? Do diets centered around cucumbers, tomatoes, or bananas for weight loss actually work? Is sugar-free healthier than sugar-laden products? Should we drink milk or eat cheese? The plethora of health and diet plans confuses the average person. As the author of this book expresses, in the realms of science and medicine, few fields are as rife with internal conflicts and lacking consensus as nutrition. There's a dearth of rigorous experimental studies supporting the diverse dietary guidelines and their proclaimed health benefits. The author of this book, Professor Tim Spector, is a professor of genetic epidemiology at King's College London, overseeing the world's richest database of twins information. He is also a senior researcher at the UK National Institute for Health Research. In his quest for answers to these questions, he and his team of experts, spanning 50 individuals, conducted over 2 decades of research. Ultimately, they revealed a fact nearly ignored by everyone: the pivotal role of the human body's gut microbiota in overall health. Tim's extensive twin studies unveiled that besides genetics accounting for 60% to 70% of individual health differences, the remaining disparities heavily hinge on the health of our gut microbiota. This is because under different dietary habits, gut microbiota generate distinct key chemical compounds, thereby altering hormone levels, metabolism, and immunity, thereby impacting our overall health. Therefore, understanding and tending to our gut microbiota, discerning what benefits them, is the crux of a healthy diet. I'll break down this book into 2 parts. First, the effects of different foods on gut microbiota. Second, how to tend to your microbial garden. Let's start with the first part, the impact of food on gut microbiota. Firstly, we need to understand what microbiota is. Microbiota collectively refers to organisms visible only under a microscope, the oldest life forms on Earth. They include bacteria, viruses, fungi, and some small protozoa. Among these, viruses lack cellular structure and must parasitize living cells. Bacteria are single-celled organisms without a nucleus, while fungi possess nuclei and can be single-celled or multicellular. Though unseen, these microorganisms exist in vast numbers. Broadly, gut microbiota encompasses all microorganisms residing in the human intestine. The gut microbiota discussed in this book refers to the bacteria, numbering around 1,000,000 trillion, residing in the intestines. Sounds staggering, right? How do these numerous bacteria enter our bodies? Well, from birth, we encounter bacteria. An infant, initially sterile in the womb, acquires bacteria after passing through the mother's vagina, getting coated with her urine, feces, and skin bacteria. When the baby ingests the first breast milk, the bacteria from the lips, mouth, or mother's nipple, protected by the alkaline milk, safely reach the intestines. Under suitable conditions, even with a small initial amount, these bacteria, due to their division every 40 to 60 minutes, can multiply exponentially overnight to billions or even trillions. Hence, influenced by genetics, diet, and environment, each baby gradually forms a unique gut microbiota community. Now, let's get acquainted with the million invisible friends in our bodies. Gut bacteria can be categorized into 3 types: beneficial probiotics, conditionally harmful bacteria, and truly harmful ones. Probiotics, the ones we ought to safeguard, directly impact our health. Typically, probiotics prevail in the gut, inhibiting harmful bacteria, maintaining our health. It's only when there's an imbalance in gut flora that conditionally harmful and harmful bacteria dominate, wreaking havoc on our health. What determines the health of gut flora? The author's research found that food directly influences gut microbiota health. The author selected some controversial daily foods like fats, alcohol, coffee, and chocolate to study their effects on gut microbiota and human health. Let's start with fats. Many people consider fats unhealthy, believing low-fat diets are healthier. Fats can be saturated or unsaturated. Saturated fats are mainly found in animal fats, while unsaturated fats are in plant and fish oils. Saturated fats lack double bonds in their molecular structure, making them chemically stable. But are they all truly unhealthy? Studies show the French consume more saturated fats than the English and Americans, yet their heart disease rate is only a third of England's, and their average lifespan exceeds the Americans by 4 years. About a third of the saturated fats the French consume come from dairy, especially milk and cheese. The French per capita dairy consumption is nearly double that of the English and Americans. Does this imply that saturated fats in dairy are beneficial? To ascertain the impact of saturated fats in dairy on health, the author conducted an experiment comparing diets with and without dairy. When both groups restricted calorie intake to lose weight, the group consuming dairy lost more body fat, which is beneficial for heart health. Similarly, a Spanish team observed a slight weight reduction among those regularly consuming full-fat yogurt after a 6.5-year study of 8,000 subjects. But not all saturated fats are equal. In a 12-week trial with 49 volunteers following a low-fat diet for 6 weeks, then divided into 2 groups, one consuming cheese, the other butter, the butter group experienced an increase in blood lipids and cholesterol, unlike the cheese group. This indicates that not all saturated fats are equally good or bad. Perhaps you've noticed the key factor, probiotics. Undoubtedly, yogurt and cheese are rich in probiotics, while milk, as commonly consumed, undergoes pasteurization but retains some heat-resistant bacteria or probiotics. In contrast, butter contains very few microorganisms. To prove that microorganisms indeed make saturated fats better, experiments with mice revealed that living in milk fostered probiotics promoted the generation of bile salts, crucial for removing harmful fats. Does this hold for humans too? Montreal researchers found that high cholesterol patients consuming probiotic-rich yogurt for 9 weeks experienced a 10% decrease in harmful fats and an increase in protective fats. Therefore, whether the saturated fats you consume are beneficial depends on whether they're rich in microorganisms. Saturated fats enriched with microorganisms can be part of your daily diet. Let's delve into unsaturated fats after discussing saturated fats. Unsaturated fats contain double bonds in their molecular structure and are generally viewed more favorably than saturated fats. You might have heard about the health benefits of olive oil rich in unsaturated fats. Does it hold true? In the early 21st century, Spanish scientists conducted a study involving 7,500 individuals aged over 60 with high cardiac risk. Volunteers were randomly assigned to 3 diet groups, one on a low-fat diet, another advised to consume more fish, vegetables, and any meats, dairy, or oils, and the third group, similar to the second but supplemented with 30 grams of nuts and around 60 milliliters of extra virgin olive oil daily. The experiment lasted for 4.5 years, revealing that the olive oil group had the lowest rates of heart disease and stroke. Their lipid profile, blood pressure, blood sugar, and other health indicators also displayed the best results. The reason behind olive oil's health benefits lies in its influence on the body's microbiota. Around 80% of the fats and nutrients in olive oil reach the colon before absorption, directly interacting with gut microbes. These microorganisms feed on the fatty acids and polyphenol in the oil, producing antioxidants that eliminate harmful substances within cells. Additionally, they generate short-chain fatty acids during this process, activating the immune system, reducing harmful lipid levels, and inhibiting the growth of detrimental bacteria like E. coli and H. pylori. So, fats aren't as unhealthy as imagined, and a low-fat diet might not be as healthy as believed. Involving the right fats benefits the flourishing growth of our intestinal microbial friends, thereby contributing to our health. Beyond fats, alcohol's impact on health is perplexing. Is alcohol beneficial or harmful? Some argue that alcohol consumption is detrimental to health, evidenced by Russia's high alcohol-related death rates. Despite being one of the world's heaviest drinking nations, a quarter of Russian men still die before 55 due to alcohol-related health issues. If alcohol beverages are harmful, why do the French, fond of red wine, have only half the heart disease and stroke mortality rates compared to the less wine-loving English? Analyzing 34 observational studies, it was found that consuming a small glass of red wine daily significantly reduced the risk of heart attacks and overall mortality. To explore this further, a Spanish research team conducted an experiment involving volunteers divided into 3 groups. One provided regular red wine, another low-alcohol red wine, and the third with spirits. After 3 months, all groups exhibited increased diversity in gut microbes, particularly those consuming red wine, where beneficial bacteria like Bifidobacteria and Prevotella significantly increased. Another study involving 8,000 participants found that regular wine and beer consumption significantly increased gut microbial diversity. Experts believe it's not alcohol itself but certain beverages like wine and beer containing polyphenol and prebiotics that foster probiotic growth, aiding our health. However, alcohol has been clearly identified as a carcinogen, urging us to weigh its pros and cons carefully. Despite the global prevalence of coffee consumption surpassing that of alcohol, its impact on health remains debated. Some argue excessive coffee intake leads to anxiety, insomnia, and irregular heartbeat. Additionally, during roasting, coffee beans may generate carcinogens. However, 26 independent prospective studies involving over 1 million coffee enthusiasts from Europe, the USA, and Japan concluded that drinking 3 to 4 cups of coffee daily reduces mortality by about 8% and lowers the risk of heart disease by 20%. Yet, coffee doesn't increase or decrease cancer risks. The benefits of coffee stem from its diverse compounds, including over 1,000 chemicals and dozens of antioxidant polyphenol. It also contains fiber, a prebiotic that nourishes intestinal probiotics. During fiber breakdown, short-chain fatty acids, particularly butyrate, are produced, aiding in hormone release, blood sugar regulation, hunger suppression, and reduced cancer levels. Drinking a cup of coffee in the morning stimulates the activity of your microbes, working toward your health. Now, let's discuss the revered chocolate, which is primarily composed of cocoa beans. Evidence suggests that cocoa, comprising over 300 chemical compounds, particularly flavonoids, has clear health benefits. Flavonoids are antioxidants that affect intestinal microbial functionality. In a clinical trial, volunteers consuming a flavonoid extract from cocoa for 4 weeks showed increased populations of beneficial bifidobacteria and lactobacilli in their intestines, coupled with decreased harmful Firmicutes bacteria and reduced inflammation markers. However, the beneficial effects of chocolate depend on its cocoa content. Only chocolates containing over 70% cocoa have health benefits. Lower cocoa content chocolates are often laden with sugars or additives. Consuming enough flavonoids from a lower cocoa chocolate might require consuming 3 to 5 times more, risking weight gain and tooth decay. Therefore, the cocoa content determines whether the chocolate you consume is healthy. The quality of the food we ingest largely depends on whether it can be utilized or appreciated by our gut microbes. Taking care of our gut microbes might be advantageous even if we don't have a winning genetic hand, ultimately benefiting our health. So, how do we tend to our microbial garden? It's a dual approach, consuming the right foods and selecting proper dietary habits. Starting with eating the right foods, beyond cheeses, yogurt, olive oil, coffee, chocolates, and moderate wine or beer, it's essential to include foods rich in fiber. Fiber, primarily beneficial due to its prebiotic content, supports the growth of gut bacteria. What foods are high in fiber, aside from coffee? There's a diverse range: oats, legumes, fruits containing soluble fiber, whole grains, nuts, husks, and various vegetables housing insoluble fiber. While all fiber types are broken down by gut bacteria, vegetables are generally considered best, followed by whole grains, with fruits' fiber impact being less conclusive. In essence, a diet rich in vegetables, moderate whole grains, and limited fruits ensures adequate fiber intake. Now, on to foods that aren't favorable for our microbial garden. High sugar items like various sugars and refined grains disturb the balance of gut bacteria. Sugar leads to cravings, resulting in excessive intake, often accumulating as visceral fat, harming health. Liquid sugars are particularly harmful, including seemingly natural and healthy juices. Can artificial sweeteners replace sugar? Extensive trials with mice and human volunteers showed artificial sweeteners, like aspartame, sucralose, and saccharin, raised blood sugar levels significantly compared to natural sugars. They also adversely affected gut microbes, reducing diversity and quantities, particularly impacting beneficial bacteria. Artificial sweeteners also promote the production of two harmful short-chain fatty acids, disrupting gut microbial functionality. Moreover, these additives in food products might have unknown and considerable effects on intestinal microbes, potentially reducing their quantity, diversity, and influencing our immune systems. Despite the association of low-calorie artificial sweeteners with health, frequent consumption in snacks proves detrimental to our microbial garden. For those craving sweetness without the health issues, opting for pricey but healthier natural sweeteners like stevia or erythritol is advisable. Trans fats, another substance familiar to many, are detrimental to our microbial garden. They're artificially produced from natural fatty acids and are present in various food ingredients, including hydrogenated oils, cocoa butter substitutes, margarine, puff pastry, and vegetable shortening. Trans fats significantly increase the incidence of cardiovascular diseases, cancer, and diabetes. How do they affect gut microbes? As synthetic substances, they obstruct the function of small molecule fatty acids, crucial in relaying information between gut microbes and our immune and metabolic systems. Reducing trans fat intake involves avoiding high-temperature fried foods and products containing trans fats, such as hamburgers, fries, fried chicken, pastries, cakes, chips, and cookies. These junk foods don't just lead to weight gain, they also harm health by influencing gut microbes. Finally, let's explore something not exactly food but frequently introduced into our bodies: antibiotics. The benefits of antibiotics are apparent. During World War II, they saved the lives of millions threatened by lethal infections, earning human trust for a considerable period. However, are antibiotics entirely safe? Not necessarily. The author mentions a pair of identical twins whose gut microbial differences were so vast they resembled strangers. It was discovered that this disparity was due to multiple antibiotic courses in their childhood, eliminating the maternal gut microbes they'd acquired. More critically, excessive antibiotics kept their gut flora in constant disarray, fostering the overgrowth of harmful bacteria, leading to autoimmune reactions. As a result, the sisters suffered ailments like arthritis, nephritis, and ulcers as they grew up. Another victim of antibiotic side effects was 2-year-old Aaron. To treat an inflamed insect bite on his leg, doctors administered 2 antibiotics for 10 days, causing severe colitis. Worldwide, half the children diagnosed with this ailment lose their lives due to reduced gut microbial quantity, weakened protective effects of beneficial bacteria, and the proliferation of pathogenic bacteria, leading to compromised immunity and gut barriers. Moreover, a study involving 12,000 children indicated that antibiotic use before 6 months of age heightened the risk of altered physique and obesity by 22% over the next 3 years. Microbiologist Marty conducted experiments on mice, revealing that post-antibiotic treatment, gut microbial compositions changed significantly, reducing beneficial bacteria while increasing hormones linked to obesity and hunger, consequently raising weight and body mass significantly, even with antibiotic doses far lower than therapeutic levels. Who could have imagined that antibiotics might cause lifelong obesity in certain individuals? Of course, emergencies warrant medical attention, but for general minor illnesses, allowing the body time to heal naturally might be preferable. While antibiotics may alleviate immediate discomfort, they deal a devastating blow to our microbial garden. If antibiotics are unavoidable, concurrent intake of probiotics, yogurt, or foods rich in probiotics like vegetables and whole grains during medication can promote the growth of beneficial gut bacteria. Now that we know the foods suitable for our microbial garden, selecting the right dietary approach is equally crucial. The author emphasizes intermittent fasting, also known as intermittent energy restriction. In this regimen, 5 days entail normal eating, while 2 days restrict intake to 1/3 of normal calorie requirements. Intermittent fasting isn't just for weight loss, it holds additional health benefits. In 1956, a study in a Spanish nursing home divided 120 elderly individuals into 2 groups, one with fluctuating daily calorie intake and the other following a consistent diet. After 3 years, the alternating group had half the mortality rate and odds of contracting ailments like influenza compared to the consistent eating group, dispelling the belief that regular eating was superior. To understand this, researchers experimented with mice, discovering that the most active gut bacteria during feeding were Akkermansia, which thrive on shed intestinal cells, stimulating cell metabolism, increasing gut bacterial diversity and activity, significantly influencing the immune system. However, prolonged eating can cause these bacteria to harm the gut lining. Therefore, occasionally skipping breakfast or missing lunch due to a hectic schedule is inconsequential as long as prolonged fasting isn't a habit. Aside from focusing on what and how we eat to encourage robust growth in our microbial garden, there's another aspect to consider. Surprisingly, excessive emphasis on hygiene isn't conducive to diverse gut bacteria development and can increase allergy susceptibility. Epidemiologist David, studying infant asthma and eczema data, discovered that infants living in damp, crowded, and less hygienic environments were less prone to these conditions. Conversely, meticulously sterile environments led to increased allergic ailments. The Amish children in Indiana, living amid dust, hay, animal hair, and unsterilized dairy consumption, had a mere 7% allergy incidence. In contrast, Swiss children with similar genetics had 7 times more allergies. Multiple studies indicate that rich, diverse microorganisms from unclean environments enrich our internal microbial garden, fostering a healthy and varied gut microbiome, activating the immune system appropriately, reducing the risk of exaggerated allergic responses. Hence, feel free to pet animals and let your children play in the grass. Nature's diverse microorganisms are a gift to our health. Here's the method to manage our microbial garden. It's not just about choosing the right food. Intermittent fasting can also give our microbes a break. Avoiding overly sterile environments is essential for gut health. The in-depth study of gut microbes made the author realize that everyone's genetic makeup and inherent gut microbiota are unique. There's no one-size-fits-all diet. So, when you hear claims about specific diets improving health or promises of health and weight loss through eating just apples, bananas, or tomatoes, take it with a grain of salt. Your body isn't just yours, it's also a garden of countless microbial influences. We share our fate with these microorganisms. Therefore, throughout our lives, it's our responsibility to take care of them because that's also taking care of ourselves. Alright, that's the conclusion of The Diet Myth. Until next time, thank you all for your support and attention. Please subscribe to the Tim Booker channel, like, and share this valuable knowledge with friends. Let's combine wisdom and practice to achieve our financial goals and create a better future together. Thank you, and goodbye.